Greetings, physicists, and welcome to your special seminar on solving physics problems. Solving physics problems is often complicated, and as a result, it's sort of easy to miss steps and get tripped up. So I wanted to give you sort of a blueprint, foolproof problem-solving method, if you will. There are 6 steps, beginning, of course, with reading the problem. After that, you want to take the important pieces of information from the problem, things that we call known quantities. They have to give you a certain amount of information when they state the problem, otherwise it's not a solvable problem. Step 2, after that, generally you want to try to draw a diagram. This is very often very helpful. After that, you want to consider the relevant theories so you know what to do to try to solve the problem. And then once you have it set up, you want to check the units to make sure that everything checks out. And finally, you plug in the numbers and the problem should basically solve itself at that point. Oh, good. That's Ninja. Everybody say hi, Ninja. So I have produced a sample problem as well as a handout that details this problem-solving process. And there should be a link to the problem-solving handout and therefore the sample problem on the problem-solving page. In any case, if you want to go and have a look at that, if you haven't already, this is a good time to pause it, but if you want to go and have a look at it so you can follow along, we can go through this sample problem together. The sample problem reads, you travel with constant velocity down the hallway of the science building for 22 seconds. During that time, you travel 33 meters down the hallway. What is your velocity during this time? No, Ninja, I need a pen. So we've already completed step 0 and read the problem. Now that we've read the problem, we have to try to figure out what our known quantities are, the clues in this problem that they are giving to us so that we can try to solve it. I apologize, I had to go and find the eraser here. Oops. Okay, so we have 2 important pieces of information here, the first of which is you walk down the hallway for 22 seconds. That means our time is 22 seconds. During that time, you travel a distance, let's call it, I don't know, d. Our d is 33 meters. Okay? Note that both of these quantities have 2 significant figures. Okay, at this point we want to try to draw a diagram. And in this case in particular, it's not very complicated. In some cases, a diagram may not be all that necessary or all that helpful, but 9 times out of 10, they're usually pretty handy. Okay, so let's say we start here and we walk down the hallway to this location, and this distance that we travel is 33 meters. Okay, now we have to figure out the relevant theory. We know the distance that we've traveled, d, and we know the time elapsed, t. Now the problem is asking for us what is our velocity during this time. And if we go back to the definition of velocity, velocity is distance over time. Seems pretty straightforward, right? That is our relevant theory. That's going to work for us. Now, just to make sure that we're not crazy, the units for velocity are meters per second, right? The unit of distance is meters, the unit of time is seconds, so meters per second equals meters per second. We are good. Everything checks out. Okay, finally we want to plug in the numbers. Our velocity is distance over time. The distance is 33 meters. The time is 22 seconds. 33 divided by 22 is 1.5 meters per second. Note that the answer has 2 significant figures, just like both of our principal pieces of information. Now, sometimes when you divide, you may end up with more or fewer, but remember the rules for division. and multiplication is that you have to keep the fewest number of significant figures in your answer. And for addition and subtraction, you keep the fewest number of decimal points past the decimal, right? I hope you found this helpful. Of course, if you have any questions, please email me. Come to my office hours, get a hold of me any way you can or need to, so that we can discuss any gaps in understanding or information. I hope you've enjoyed this, and I'll see you soon.